Alright, you drive an average 750 miles per week in a car that gets 28 miles per gallon. I'm going to separate this out a little bit so maybe we can look at it. With gasoline priced at $3.40 per gallon, what would the difference in total weekly cost for gasoline if you start driving an SUV that gets 20 miles per gallon? Okay, so let's take a look at our old car, and then we'll eventually partner it up with our new car and just kind of need more space than that. Okay, so let's start with the old car. So you drive 750 miles per week in a car that gets 28 miles per gallon. Okay, so how much are we spending on this current car? Well, if I'm trying to drive 750 and each gallon I can only get 28 miles, well, how many gallons is that, right? So I want to figure out 750 divided by 28, and that's going to give me a number, which I will tell you what that is right now. 750 divided 28, so it's about 26.8. Now, I'm going to keep using Excel to kind of help with this here. Okay, so if I got 26.8 gallons, then I want to take that 26.8 and I want to multiply it by how much it costs per gallon. So 340. So equals that lovely number we just found times the 340. And so I'm spending $91.07. All right, $91.07 on the old car. All right, on the new car, let's see, I'm going to drive the same 750, but this time I only get 20 miles per gallon, so that's a lot worse. It's going to be more expensive. So 750 equals 750 divided 20, so 37.5 gallons total. And I want to take that 37.5 and I want to multiply that by the same 340. And that'll tell me how much money I'm spending. So equals that number times 3.40. So it's been 127.50. Okay, and I'm asked to find the difference in the weekly total. So I need to subtract. Oops. Sorry, got a lot of hand there. So I need to know what 127.50 minus 91.07 is. And that's where I'm going to let Excel do the heavy lifting for me. So take that number minus that number, and I get 36.43. So a difference of $36.43. All right, number 8, suppose you want a $200,000 retirement after, oh, wait a second. This is the finance spreadsheet. So I'm going to go grab that real quick, and then we can decide what it is we want to do with the spreadsheet. But I am reminded that we need that. Okay, so let's take another look at this and think about what it is we're being asked to do. We want to have $200,000 in the future. How much do I need to deposit now? Right there, deposit now. If we can get 9% compounded daily. Okay, so when it says deposit now, they're not saying each month. They're saying one lump sum. In class, I would describe this as grandma gave me a chunk of money. How much money do I need to get from someone that I can just let sit in the bank so that I can earn this magic amount? So I'm being asked deposit now. So let's look at our chart here. Didn't say the word simple, didn't say the word compounding, so no sense at all to even look at those boxes. This was something in the future. This was time, wasn't asked about that. Interest, wasn't asked that. Payment means each month, and present value means big amount of money now. So this is a present value question. Okay, so I need an APR, which is 9%. Compounding, let's see, does it give us one of our vocab words? It does. It says compounded daily. Okay, so what I have to do then is I need to think, when it says compound daily, how many times a year is that? There are 365 days in a year. So that's my compounding. My future value is that 200,000 that we want to have set aside. I don't have any money that I'm setting aside here, and I want this in 40 years. So the magic amount that I need to set aside now is $5,467.17. Okay, so hopefully that helped. Let's move on. Okay, so in this question we're said, sounds kind of the same question, doesn't it? We want to have $135 after 13 years. We get this 8.7% APR. Compounded monthly. Oh, that's new. So we got to remind ourselves that at some point we're going to have to put in a monthly number instead of a daily number. How much should you deposit at the end of each month? Okay, so this whole phrase right here, now they're saying I'm paying something each month. So they're asking me, what's my monthly payment? Okay, so when I go to the spreadsheet, I didn't see the word simple or continuous compounding, so I don't need either of these boxes. I do need the payment box, so I'm going to kind of move this over here. And I want to type that as 8.7. Compounding periods, they said compounded monthly, so that's 12. I want to have 135,000. Let's try that again. Present value is 0. Future value is 135,000. And I want to have that after 30 years. So I need to set aside 469.17. Okay, so if I set that aside, then I should be able to hit that goal. All right, let's keep going. Okay, this one says calculate the monthly payment for home mortgage. Okay, so we're asked to find a payment again. So we'll have to see how this changed in our scenario here. So I want to use the payment box, given a very detailed APR. Ooh, 5.875. Sounds so specific. Okay, compounding periods. Okay, so this one, sort of in context, we have to think, when I take out a home loan, how many times a year do I have to pay? 12. Okay, so compounding stays 12. Yay. My present value is how much do I currently owe, and I currently owe that 189,000. I'm trying to pay that down to 0, and I have 15 years to do it in. So 1,582.15 would be the payment that'll get that done. Okay, so just wanted to let you see that summatively in case you needed to go back and reference that. All right, let's keep going. Okay, so in this question, we're referencing the Alice in Wonderland story. So we're told she eats a piece of cake and grows 6 times her size. And then we're asked to make a statement about her dress. Okay, so even though this is talking about eating cake and growing in the size of her dress, what we really want to start with is what in our class are they trying to get us to think of? And so when we studied this in the geometry lesson, we talked about the relationship between perimeter, area, and volume. So even though I'm only asking one characteristic of this in this question, on the final I could ask anything. Could be anything related to these facts. So what do we know? We know she grows 6 times bigger, so given to where she is now versus 6 times. So when we talk about the fabric on her dress, is clothing a perimeter thing, an area thing, or a volume thing? Now, even though she increases by size 6, the clothing itself is a 2-dimensional. It's a flat thing. Like when it's in your drawer or hanging in your closet, it's a flat thing that covers a 3-dimensional object. So the clothing itself, the fabric, will only be an area measure. And so that is actually going to get bigger, not 6 times, but 6 squared times. So 6 times 6 is 36 times. So her clothing is going to get 36 times bigger. I could have asked how much bigger does her belt get. If I asked how much bigger her belt would get, that would be 6, because that's a perimeter thing. I could ask how much bigger does her waist get, because that's now part of her body. That's a volume thing, in which case it'd be 6 cubed. But again, you're supposed to think of those facts there.